Number system, digital electronics number system. So number system which is used to count the discrete units, so which is called number system. There are four number systems are most commonly used in digital electronics: binary number system, decimal number system, octal number system, hexadecimal number system. So these are the four most commonly used number system for the arithmetic for digital electronics, in the digital electronics. So decimal number system, so we commonly used all the ways. The binary and hexadecimals are most commonly used for the processor. So let's we discuss one by one number system. Okay, first decimal number system. So decimal number system, it contains 10 numbers, that is 10 digits. So there are 10 digits are there in the decimal number system, so which is called 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Like, so there are 10 numbers are there in the decimal number system, so which is called digits. So there are 10 digits are there in decimal number system. So at the same time, it is also known as base 10 or radix 10 number system. So the base or radix, that is nothing but the, so the depending on the number system contain numbers, how many numbers are contains in the number system, so which is called base of that number system or radix of that number system. Okay, this is the only example of decimal number system. So the decimal number system which contains these all numbers, that is 0 to 9. So 0 to 9 numbers are there, and so it represents the base 10. So at base 10 it represents the decimal number system. And this is the position values of power of base number system, that is which number system we are using, that positions value, that is here the power of base 10. So this is the decimal number system, so this base is 10. So the based on base, so there is a fraction point is there. From the fraction point, so we can give the positions value, that is weightage of the each position. So from the decimal point left hand side, so 10 power 0, and the next digit is known as 10 power 1, and the next position of the decimal value is known as 10 power 2, and then 10 power 3, so on. So from the fraction point left hand side, and the right hand side from the fraction point 10 power minus 1, 10 power minus 2, next position value, and then next values which is called 10 power minus 3 and 10 power minus 4, so on. So this is the position value or weights of the that decimal number system. Okay, next binary number system. So binary number system which contains two numbers, only 0 and 1. So there are two numbers are there in the binary number system, 0 and 1. So it is known as binary digits, that is simply called bits. So in the decimal number system we will call each number as a digits. So here we can call as a bits. Binary numbers, each number which is called bits, that is binary digits. Its base is 2. So the group of 4 bits, that is 4 binary numbers, which is called nibbles. So like this is 1 0 1 1. So here is the 4 binary numbers are there. So this 4 group of binary one is called nibbles. So next group of 8 binary numbers, which is called byte. So 1 byte is, that is 8 digits, 8 bits. Got it? Okay, so here is the 8 binary numbers are there, 1 1 0 0 0 1 0 1. So this 8 group of number is called 1 byte. This is the example of binary number system. So that is 101.01. It represents base 2. So in the base 2 represent the binary numbers, because it contains, binary number contains only 2 numbers, zeros and ones. And this is the positions of that is weightage, the position values, like same one previous decimal, like this one. So instead of, so we have to use the base value. So any number system, so which number system you are using, based on that base value is used. Here the binary number system, so we have to use 2 power 0, 2 power 1, 2 power 2, so like this. So from the left hand side fractional point, and then right hand side of 2 power minus 1, 2 power minus 2, like this. Next number system is octal number system. So octal number system, so which contains 8 numbers. So there are 8 numbers are there, that is 0 1 2 3 4 5 6 7 8. So totally 8 numbers are available in the octal number system. So octal number system, that is group of 3 binary numbers, which is called the octal number system. So the when we represent in the binary, so we have to mention in 3 bits, that is 3 binary bit we have to use for the each digit or each numbers. So is then the example of on the octal number system. So octal number system, so which contains the 0 to 7. So within that 8 numbers, so it contains, and its base value is 8. So it represents the octal number system. And then position values of base 8, that is power of base 8. So from the fractional point, so left hand side, that is base value is here 8. So 8 power 0, 8 power 1, 8 power 2, 8 power 3, 8 power 4, and so on. So like from the fractional point right hand side, so 8 power minus 1, 8 power minus 2, minus 3, minus 4, and so on. So next each position values. So another number system, hexadecimal number system. So in the hexadecimal number system, it has 16 numbers are there in the hexadecimal number system. So that is 0 to 9 numbers, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then after that, instead of 10 we are telling in the normal life. So instead of that, so here we are using A, B, C, D, E, F. So A represent the 10 and B is the 11, C is the 12, D 13, E 14, F 15. So there are 16 numbers are there in the hexadecimal number system. So in the hexadecimal number system, so 0 to 9 and A, B, C, D, E, F. So totally 16 numbers are there. So here in the hexadecimal it represents the 4 bits, that is 4 digit of binary numbers. So each numbers we can represent as a 4 bits, 4 group of 4 binary numbers. In that term, so we can represent the hexadecimal numbers. So 1E5, that is, so E, that is, these are all the hexadecimal numbers. So this hexadecimal number contains, that is 0 to 9 value. So any number from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So any value is there, and then apart from that, so A, B, C, D, E, F. So this alphabet also included in the hexadecimal number system. So that's why it contains like numbers and alphabets, hexadecimal number system. So in the 16, that is the base of the hexadecimal number system. Like similarly, the position values of, so each digits, so here we have to use the base value 16. So 16 power 0, that is from the fractional point first digit, and next position digit number power is 16 power 1, the next one is the 16 power 2, and then another one is the 16 power 3, 16 power 4, so on, like that. So and then similarly, the right hand side of the fractional point, so 16 power minus 1, and the next position digit weightage is 16 power minus 2, and then 16 power minus 3, 16 power minus 4, so on. So far, so we discussed number system. What are the number system we discussed? Binary number system, decimal number system, octal number system, hexadecimal number system. These are the 4 number systems are most commonly used. Okay. Next, number base conversion, that is one number system to another number system conversion. So how to convert the one number system to another type of number system. So for example, so the here what we discussed so far, so all 4 number systems are there: decimal number system, binary number system, octal number system, hexadecimal number system. So all these 4 number systems are there. So decimal to binary, how to convert decimal to binary, or how to convert decimal to octal, or how to convert decimal to hexadecimal. So like this, octal to decimal, binary to decimal, hexadecimal to decimal, and then decimal to octal conversion, decimal to binary conversion, decimal to hexadecimal conversion, and then that is decimal to any base conversion. Okay, in the dotted line it represents the decimal to any base. So it may be a binary conversion or octal conversion or hexadecimal conversion. And then any base to decimal conversion. In the straighted line it shows the any base. So octal to decimal, binary to decimal, hexadecimal to decimal. And then apart from these two conversion, intermediate conversion also there. That is octal to binary, binary to hexadecimal, or hexadecimal to binary, binary to octal. So like intermediate conversion also there. So now we will discuss one by one base to another base conversion. So how it is happening. Okay. So first, so decimal to any base conversion. So a decimal number is given, so that decimal is converted to binary number or decimal to octal or decimal to hexadecimal, that is decimal to any base conversion. So first we see the steps. So what we have to do for the decimal to any base conversion. First step, so integer part. So if the given number is having integer and fractional part, so first we have to do the integer part, that is successive division. So you have to do the integer part, successive division. Divide the number by base. So which base we want to convert? So for example, I want to convert decimal number into binary number, so that base is 2. So I have to divide it by 2. Or if I want to convert decimal number into octal number, so its base is 8. So I have to divide it by 8. So like that. So base. So divide the number by the base. So that integer part, first we have to divide by the base. Next. So after dividing, so we will get the remainder and quotient. So remainder, we will take it as a coefficient, that is the first coefficient of that conversion part. So when we divide one integer part, so we will get the remainder. So that is, take it as a coefficient, and then there is a quotient is there. Then again that quotient is used to divide by the base. Then again I have to divide the quotient by the base. So which base I want to convert, base, and then that I have to divide by the quotient, and there is available a remainder. So remainder, another remainder is, take it as a next coefficient. So like that, so I am repeating until, so till it is end. That is the integer part procedure. And then fractional part. So how to do the fractional part if it is there in the fractional part na. So how to do? So integer part we have to do the successive division. Fractional part we have to do the successive multiplication. So we have to do successive multiplication for the fractional part. So first multiply the number by the base. So what number, that is fractional part, we are having, so that number is multiplied by with base value. So for example, if I want to convert binary, so I need to multiply with 2, or if I want to convert octal number, so multiply with 8, like that. So that fractional part into base value, first to multiply with that, and then when we are multiplying that fractional part with the base, so there is available integer. In case there is no, that integer will be take it as a first coefficient. In case there is no integer, so if it is 0, so that will take it as a coefficient as 0. And then again there is a fractional part is available, and then that fractional part is multiplied with the base, and then say process is repeated. So when we are multiplying the fractional part with the same, and there is available integer part, so that will take it as a next coefficient, and then that fractional part is again multiplied with the base, like that. So we have to do until 0 or till 3-4 digits. So this is the steps we need to follow the decimal to any base conversion. So decimal to binary, or decimal to octal, or decimal to hexadecimal. So any base from decimal, so we have to follow these steps. So only integer is there na, so we need to do the successive division, or if it is there fractional part also na, so we have to do successive division for the integer part and successive multiplication for fractional part. Okay, so let's see one example. So decimal to binary conversion. So here its base is binary, means so its base is 2. So the given example is 13. So integer part means what is the procedure? So successive division. So we have to do the successive division for the given decimal number. So here 13 is the decimal number. So divide by the base. So here base is 2. So 13 divided by 2. So 13 divided by 2, that quotient is 6. So there is a remainder also there. So remainder is 1. So what I told, that remainder will be take it as a coefficient, first coefficient. So here, so 13 divided by 2, that is equal to 6 is the coefficient, and there is a 1 remainder is there. That remainder is take it as a first coefficient, which is called, so we will represent as a A0 for identification. Okay. Now again, so I need to divide this coefficient, this quotient. This quotient is again I need to divide it by the base, divided by 2. 6 divided by 2. So when I divided by 2, 6 divided by 2, so quotient is 3. So remainder is 0. So there is no remainder, 0. So that is the next coefficient of of the binary values. Okay. Now the coefficient is 3. So again I need to divide by the 2, that is 3 divided by 2. So when I divide 3 divided by 2, so quotient is 1 and remainder also 1. Got it? So this remainder is, take it as a next coefficient. Okay. So now here the coefficient is 1. So it is not possible divided by 2. So here coefficient is 0. Leave it. So in the decimal, so 1 by 2 is 0.5, but here we are doing binary conversion. So keep it in mind. So here is, so it is not possible. So we will take this quotient is another coefficient. That is, got it? So there are 4 coefficients are there. So it arrow upwards it shows. So this is the MSB bit, that is LSB MSB bit, that is LSB means least significant bits and MSB means most significant bits. So what is that is, this is the first coefficient is the least significant bit and the last coefficient is the MSB bit. So when we are writing, so from here we need to write, that is 1101. So likewise we have to write. So this is the decimal value 13. Its equivalent binary value is 1101. That is its equivalent binary value. So we converted decimal into binary number systems. Okay, next we discuss integer part, fractional part. So fractional part, what I told, so successive multiplication. So successive multiplication, so this is the 0.625 is the given fractional part. So I need to multiply this with base. Here base is the 2. So 0.625 into 2, that is 1.25. So 0.625 into 2 we multiply, so we get 1.25. So 1 is the integer part and 0.25 is the fractional part. So what I told, so the integer part is, take it as a first coefficient. So here the integer part is, take it as a first coefficient. Then next, so we need to multiply this fractional part. So what we having here, this value is multiply with the base, that is here base is 2. So 0.25 into 2. So 0.25 into 2, if you multiply 0.5. So here integer value is 0. So this value is, take it as a next coefficient. So got it? And now again, so this 0.5 is multiplied with the base, that is 2. So here integer part is 1 and fractional part is 0. So the fractional part decimal value, that is 0.625, its equivalent binary values. So here, so we have to start from up to down. So got it? So from top to bottom, that is 0, 1, 0. So 0.625 decimal value. So its equivalent binary value is 0.101. So we have to write, you start from here. So the arrow is showing top to bottom. So we need to start here and to finish here. This is the MSB bit, and here is the LSB bit. So this is the LSB bit. So least significant bit and most significant bit. So decimal to octal number. So 175 is the given decimal example. So what we need to do? So integer partner, so we need to do the successive division with the base. Here the base is 8. So 175 divided by 8. So 175 divided by 8, that is equal to 21 is the coefficient and remainder is 7. So remainder is, take it as a first coefficient, and this quotient is again we need to divide it by the base. Here the base is 8 because octal conversion. So 21 divided by 8. So 21 divided by 8, quotient value is 2 and remainder is 5. So in the remainder values take it is known as, so next coefficient value. And now, so 2 divided by 8, that is 0, and the remainder is 2. So this is, take it as a next coefficient. So what I told, so how to take this coefficient from bottom to top. So bottom to top, this is the MSB bit and this is the LSB bit. So when we need to write, that is 257. 257. So in this way, so we have to write. This is about integer part. So next, fractional part. So how to do the fractional part, that is decimal to octal conversion. So fractional part, successive multiplication. So this value into base value, that is 8. 0.3125 into 8, that is equal to 2.5. So 2 point, this is the integer value. So this will we will take it as a coefficient. So this integer value 2 is, take it as a coefficient, and then fractional part is 0.5. Again, so we need to multiply with 8. This 0.5 is multiply with 8, that is base value. 0.5 into 8, that is equal to 4.0. So 4 is next coefficient, and here is the fractional value is 0. So 0 means we note we don't further do the multiplication. So here we stop. That is, so how I told how to write this coefficient? So from top to bottom, that is 0.24. So 0.24 is the equivalent decimal octal value of this number 0.3125.